involved in writing the NHI Bridge Maintenance Reference Manual. Jason currently serves as a senior bridge engineer for HDR in their East Lansing office. So right before we welcome Jason, just a couple quick housekeeping. This is a live, just a normal go-to meeting, so you have the ability to unmute yourself. We have a pretty good turnout, so I would suggest that add questions to the chat, and maybe I'll unmute and interrupt Jason here and there for some of those questions, or we can ask him at the end with unmuting. We are, looks like, already recording this. It'll be posted to the website, and that's at tsp2.org. And with that, please join me in welcoming Jason. I like to clap.
All right. Thanks, Travis. I'm going to turn off my camera here just to make sure that the quality of the meeting stays high. Just had it on for a brief moment. Like Travis said, I spent 12 years of my career, 13 years of my career as the Michigan DOT structure maintenance engineer. In that role, my primary responsibility was to keep our maintenance crews going. MDOT had anywhere between 10 and 14 direct force maintenance crews that worked solely on bridges throughout the year. So the unit I supervised and myself, we would travel around the state. We would teach them how to do bridge maintenance. We would teach our local agencies how to do bridge maintenance as well. We would coordinate on projects together to keep our bridges maintained in preventive maintenance, as well as more proactive maintenance. That included buying them the materials, the equipment, and everything, and assisting them with their projects. I like to tell people that I did run a jackhammer one time before they told me I wasn't allowed anymore. So I've actually, when I give these presentations, I've had the privilege of actually being out in the field and doing most of these projects. So today's topic is bridge joints. Bridge joints are very important, and we're just going to dig in, and hopefully by the end of this presentation, you'll know why bridge joints are so important. Okay. So here's the outline. So we're going to talk about how to identify what type of joint you have on your bridge. We're going to talk about simple joint maintenance, like why should we do the joint maintenance? When you go out to your bridge and you're looking at a joint, help you identify what problem you're seeing. We're going to go through some simple maintenance, which I call problem prevention. And then we're going to go through some advanced maintenance, like a strip seal replacement. Joint identification. A lot of this stuff in the joint identification comes, I pulled directly out of NCHRP 12-100, which is a report called the Guidelines for Maintaining Small Movement Bridge Expansion Joints. It's free. I highly recommend Googling this and keeping this handy. It is a great resource for small movement joints. Most of you are going to have small movement joints for, I mean, a lot of local agencies are going to have small movement joints. I think the vast majority of local agency bridges are on the smaller side. I understand that some have some substantially large bridges that have more complex joint systems that we're not going to talk about today. So basically today we're talking about the small movement joints. Just going to strip this really down to the basics, talk about, you know, what is joint movement. Joint movement is displacement caused by temperature changes in your bridge. You have a gap that your joint will be set at the time of construction. You'll have a seal at that gap to protect your substructure and superstructure. Sometimes you'll have it called out as a membrane, a gland, or a gasket. Just depends on where you're from in different areas of the country and DOTs, what kind of language you use. Some joint systems have what's called a blockout, which is an area adjacent to the joint that's not necessarily of the same concrete deck material. It'll be a different kind of material. It'll be a space that was left out for a joint to be installed or easily replaced. And then inside that block out, you'll have a joint header material that's typically a non-cementitious concrete material. Here's just a cross section of a joint to kind of see what I was talking about. So like I said, joints, they permit expansion and contraction, or sometimes even rotational movement. They can be located at your piers, abutments, pin and hangers, and sometimes they're located off the bridge on what's called a sleeper slab. Here's a cross section of an asphaltic plug joint. You can expect movement or it can handle movement up to 1 inch. You can see that it has a backer rod in your joint gap and some material. It has a plate that bridges over that gap, and then it has a asphaltic material over the top that can handle that 1 inch of expansion and contraction. It's a little bit more flexible than your HMA overlay. We have what's called open cellular compression seals. The seal is compressed prior to placement in the gap. These can come in various sizes and handle movement up to a 2.5 inch wide gap. The bottom left corner there shows what that looks like in cross section. You also have what's called a bonded seal. The seal is bonded to the concrete with an adhesive. You can get movements up to 2.5 inches. You can see there in the corner, it's a little bit different than the compression seal. The compression seal is held in by compression. This is held in by an adhesive. You also have a combination joint that's bonded and compressed, like a BEJS sold by M-Seal. Basically, this is a material that is pre-compressed, comes in 6-foot sticks, and you can stick it in the joint, and so it expands into your surface, so it's held in place by compression and an adhesive. This is an open cell joint. Can handle up to, I would say, 2.5 inch movement. Sometimes you can go a little bit bigger. When you purchase the material, you want to go with the manufacturer's recommendations, but typically your material is going to be 50% wider than the joint opening. You can see there in the bottom right, the fully expanded joint material in reference to what was put in the joint. One of your most common joints is called the strip seal, can accommodate movement up to 4 inches. Cross section of this joint shows you some of the standard components. You'll have a rail. More than likely, you're going to have an anchorage that holds to the concrete or the deck, and then you're going to have a gland that sticks into the rail. You also have pourable joint seals. It's a closed cell backer rod with some kind of pourable sealant on top, whether it's a silicone or a polyurethane. Just depends on preference. It's my understanding that polyurethane is a little better for sticking to green concrete versus the silicones. You'll also want to make sure you use like a non-sag material. Some of the pourables get really, really thin and can pour right out of your joint. All right, so I know I talked a lot about movement, and some of you are like, well, how do I know how much movement my existing joint has, or how do I determine that? I'd say go to the plans is one of your first places to look. Here's just an example of Michigan DOT. Most of their bridge plans, or all of their bridge plans, have a table that looks like this, that has the structure number and the amount of movement expected at the joint. and they'll have it for every single joint across the bridge as well as every structure. So joint maintenance, why do it? Damaged joints will leak, resulting in deterioration of your superstructure elements below. On the left, you can see we've had enough superstructure, we've had enough steel beam end deterioration that the beam is buckled and tore at the bottom flange, or I mean at the bottom of the web near the bottom flange. And on the right, you can just see a little bit of a buckling in the bottom flange, as well as just a tremendous amount of section loss, which leads to capacity loss, which leads to possibly posting your bridges. Damaged joints will leak, resulting in deterioration of your substructure elements below. You can see deterioration of the abutment on the left and substantial deterioration of a pier cap on the right. Obviously, they need to be repaired, but these types of deterioration can be avoided if we're maintaining our joints. Damaged joints will leak, resulting in deterioration of your bearing elements below. You can see on the left, we've got an H bearing that has a hole in it. And on the right, we've got a shoe-style rocker bearing, rotational bearing that's got a substantial amount of section loss on the bottom. May or may not be functioning properly. So what happens when our joints leak and then our bearings don't function properly? Well, when bearings don't function properly, you can cause superstructure and substructure damage in addition to what was caused by the leaking. On the left, you'll see a bottom flange had a little bit of a buckle in it from improperly designed and functioning joints. And on the right, one of the bearings just gave up and fell out because it wasn't functioning properly from joint deterioration. And you can see from one span to the next, there was a 4-inch drop in the deck from where the bearing used to be. So how do we identify joint problems that are going on? As a bridge inspector, when I go out and inspect bridges, I love it when it rains. I can go out right after a rain and the underside of the bridge just sings. You know, you can look at this picture here and you can see wet stains all over the place from where the joints are leaking it, and it really pops in photos. So if you're looking at the bridge on the top and you're like, well, it kind of looks like it's leaking, I'm not sure. But if you go down underneath after a rain, you can obviously see that it's we've got some issues here. Up here in the Midwest in Michigan, we get some plow damage on rails. You can see that on the left. Our plow drivers really like bare concrete on our decks during the winter time, so they'll really press down on the roadway and the bridges as they're going across, and sometimes they snag a joint rail and break it. I've actually seen so much on the right here. This joint used to be full of dirt. I've actually seen so much dirt in a joint that has pushed the gland out. This one just has several tears in it from whatever sharp material was impacted into the joint. The joint on the left, not 100% certain what's going on here. The rail is pulling away from the concrete deck. Not sure if sometimes when you're installing joints, it could have been installed improperly. It could have been installed without studs on the back of the rail, so the concrete could pull away. It could have been installed leaving the shipping bolts that go in between the two rails in place, and then when the concrete was poured, the concrete shrank, and because the shipping bolts were in place, the rail wouldn't move with the concrete deck. It pulled away. On the right here is just a standard fall adjacent to a rail. On the left, and the right, you can kind of see some adhesion failure in the pourable joint. You can see some spots that are missing from the top surface. You can also see in the header on the right some failures in the header material. So simple maintenance, I call it problem prevention. Nobody wants problems. Clean your joints. It's really, really easy. Just go out there, use a high volume of water at low pressure is best to clean your joints, clean any portion of your bridge with high volume flushing under low pressure. But if you clean out your joints and leave dirt everywhere else on your bridge, it's just gonna, next time it rains, it's just gonna go back into the joints. So if you're gonna go out there and you're gonna clean your joints, you might as well have a program in your area to clean off the whole deck surface. Just every spring, try and get out there and clean off your bridges. So it seems like a simple thing to clean your bridges, and I just want to point this out that, you know, not cleaning the bridges, you know, can have serious consequences. The bridge in Pittsburgh that collapsed, the NTSB attributed the bridge collapse to clogged drains. You know, that there were clogged drains on like 10 consecutive bridge inspection reports and they were just never cleaned out. So the water just ran over the sides and rusted away critical supports for the Fern Hollow Bridge. So that's why, you know, it seems like it's simple, but it also, you know, it's just something that gets overlooked time and time again. So I'm going to keep preaching it as long as I have breath in my lungs here. So let's see. Oops. All right. So reseal your pourable joint seals. Be proactive. Pourable joint seals, you know, they might last 10 years. They might last 5 years. It just depends on the quality that they were put in at. You're just going to want to almost get into a thought of, if I have pourable joint seals, I want to know where they're at, and I want to make sure I get them on a maintenance list, like a cyclical maintenance almost. You're going to want to get in there. You're going to want to completely remove the existing joint and sealant and backer rod that's in there. You're going to thoroughly clean the existing joint opening. You're going to sandblast the joint opening. And if necessary, if that joint is closed up over the years, you're going to want to resaw cut that joint so that you get at least, you know, 3/8 to 5/8 of an inch opening in that joint if it's closed up. You're going to install a closed cell backer rod. That is also going to be 25% bigger than your opening. So that it sticks in there, and you're going to want to make sure that it's not just stuffed in there irregular. It's going to be flat. It's going to be at 3/4 of an inch from the very top of your deck all the way across. You know, custom make some kind of guide to make sure that it's put in at the right elevation. If these joints are put in at the wrong elevation, they're not going to function properly if these backer rods are. So like I said, you're going to put in your silicone or your polyurethane over the top. You're going to recess it so it doesn't get snagged on plows. And when you're done, it's going to have this nice hourglass shape where it's adhered to the edges. It's thinner in the center, and it's uniform all the way across the bridge. That's going to give you your best results for expansion and contraction. If you just stuff this in there and push it down too far and it's like really thick in the middle, it's not going to perform. If you undersize the if you undersize the backer rod and it falls to the bottom and you just fill the entire joint opening with silicone, well, one, you're going to waste a lot of material, and two, it's not going to perform. It's just going to tear away from the edges. It's not going to be able to expand and contract unless it has this hourglass shape. It's very critical to make sure that this is installed correctly. Your pourable joint seals, though, if you have pourable joint seals that are on highly skewed bridges, you might want to think about not using a pourable joint seal, going with more of a pre-compressed joint seal. Those pourable joint seals are only good for movements normal to the joint. Highly skewed bridges have movement that's normal and transverse to the joint. And that can be handled, that's not handled by a typical silicone or polyurethane poured joint seal, but it's handled by, but it can be handled by these pre-compressed joints like BEJS on a reel here. I also had, I pulled this spec in that I wrote when I was at the Michigan DOT with a few other companies that offer small movement joint options instead of using pourables. And this is required to be used at all skewed bridges in Michigan instead of a pourable. Yes. All right. Replace leaking bonded seal joints, like a RJ Watson Sikaflex. You're going to want to remove the old bonded seal, sandblast the joint face. Then you're going to want to put in a locking adhesive at approximately 1 inch below the surface. You're going to press the gland into the opening and into the locking adhesive per the manufacturer's directions. And then you're going to go back with another locking adhesive bead applied to the top of the joint. So that'll have locking bead, adhesive bead above and below the edge of the joint. Sometimes we have glands that just went bad and the concrete is still sound. You can replace the gland. It's pretty simple. And like I said, if the rail is secure, it's pretty simple. If the rail is secure, the concrete adjacent to the rail is secure. The trickiest part of the entire operation is determining what rail you had out there, because depending on the manufacturer and what rail was supplied by the manufacturer, there could be a different size rail opening that the gland sits in, and you'll want to make sure you get that matched. You're going to want to order all your materials once you get it matched. You can probably tear out a piece of the existing and go to the manufacturer's tables and match it up to what's out there. DS Brown, I just found this online. DS Brown, I saw it at the National Bridge Preservation Conference last week, and I looked it up online. They have the strip seal removal kits that cost $775. They're actually a lifesaver. Without these kits, it is a lot of work to get these strip seal glands out of the rail. But they make it pretty simple. They even make a special tool there. That number 5 tool, I believe. Yeah, that's a clean out toolbar that can go into the existing rail that's left behind and clean out any dirt and debris that might be in there. So this is just this is some pictures from before that gland was removal tool was invented by DS Brown. Or if you don't want to spend the $775, you're going to have to go through and manually cut down the center of the rail, and then you're going to have to just brute force it out. Here's another example of cleaning the channels. When you're all done cleaning the channels and prepping them, you're going to unroll and use a lubricating adhesive. And then DS Brown also makes a tool that goes on an air hammer, a spoon-shaped tool that goes on an air hammer to help set that gland into the rail properly. If that seems like a lot of work, BEJS M-Seal makes a product that pre-compressed and bonded open cell foam material that can go in the rail. The only thing you have to do in preparation is you can see the rail is actually filled with a non-sag epoxy that cures and sets up. You can't leave that rail empty and then install the BEJS gland. Advanced maintenance, strip seal replacement. There's a partial depth option. If you have a header material, you can go back with a partial depth style rail that has anchor bars that stick straight into the concrete instead of on an angle. And then that header material is some kind of elastomeric concrete or other non-cementitious concrete that has a chemical bond to the existing concrete deck so it doesn't pop out. So it's this type of system right here. If you're out on your deck and you see this type of system and it's failing, it's easy to chip it out, place a new rail, and pour a new non-cementitious concrete header. There's all kinds of products that you can buy and look at. I'd suggest going to the AASHTO TSP2 website. It's still called that, so I'm still going to call that. And in looking at some of the sponsors and vendors that we have to select a really good header material that you know that has been trusted by the states. So full depth option, this is the boss level of joint maintenance. You're going to have to do a 1-inch saw cut along the adjacent to the joint, 1'6" on either side of your joint minimum. Just depends on the state of your concrete, how bad it is, what's wrong with it, what's going on. You'll want to look at where your diaphragms are, your end diaphragms are underneath your bridge at your joints, your expansion joints, and make sure you do removal at a minimum, like I said, 1'6" away. But if your diaphragm's further away than 1'6", you'll want to make sure you remove concrete all the way to that diaphragm, just because it makes it easier to form your joint on top of those diaphragms. Typical concrete removal, follow whatever DOT recommends in your area. In Michigan, we never allow anything on our decks bigger than a 60-pound jackhammer for any kind of deck demolition that we are going to be saving the beams. Anything bigger than that, and you could start damaging the beams, especially concrete beams. You can damage steel beams with bigger jackhammers. So just make sure you follow whatever's recommended by your local DOT. Once you get all the concrete removed, you're going to blast clean your existing reinforcement that's going to remain, your longitudinal reinforcement. You're going to plan on replacing your transverse reinforcement. It's either probably, if you're replacing your joint, it's either rotten or it'll get mangled pretty good during the removal process. So, like I said, replace exposed transverse bars. And then if there's any bars in the longitudinal direction that have broken or have more than a quarter of the original diameter missing from rust, you'll want to also splice in new bars. Look into shop fabricating your bars, or shop fabricating your rails to the contour of the bridge. If you're replacing a bridge joint, strip seal, does your bridge have a straight line crown, parabolic crown? Does it have upturns that you want pre-manufactured in? Just less field welding. Does it have an irregular kink in it, like in this diagram below? And then I recommend the glands be hot dip galvanized. That's just my recommendation. Make sure you set your expansion rail to the proper elevation. Here's some of our maintenance crews putting them in, putting the expansion rail at the proper elevation. You're going to want to have it at least an eighth and preferably a quarter inch below the top of the concrete slab. And that'll help avoid snowplow damage. At your curbs, if you run your expansion joint through your curb, make sure that at the edge of the curb and at the edge of your sidewalk that you recess the joint as well there. Don't run it straight up the face of the curb at your sidewalk. You can see on the left it got snagged by a snowplow because it wasn't recessed properly. You can see on the right that the joint is recessed properly. It's back at least a quarter to a half an inch there from the face of your curb. You can secure your rail to the existing reinforcement. That's the best way to do it. Make sure it doesn't move. And like I said, remove the shipping devices because they'll come out, the rail will come out in one piece where it's got two sides and it'll be connected by shipping bolts. And that's good for the initial installation and setting your rail and tying it down and securing it. But before you pour your concrete, you want to take those shipping bolts off. You're going to want to remove those. If you're doing part width construction, just make sure that you're really precise with placement of your rail and know that, and go into it with the understanding that you're going to need to weld the rails at the stage interface. You're not going to be able to leave that as two separate pieces. That needs to be welded as one continuous piece when you're doing stage construction. Make sure you develop some kind of system to keep the concrete out of your joint. It doesn't matter whether you use a styrofoam or a duct tape or something. You just need to make sure that you have something there to make sure no concrete gets in your joint when you're pouring the concrete. No concrete splatter gets in there when you're finishing. And to make sure that, because that'll get in your rail, you won't see it, and then when you install your gland, it'll be a spot that leaks. This, and I like to rag on engineers every once in a while about this. Don't do this. Don't detail it like this. If you look at this joint under construction on the left and poured on the right, you can see that we might have a 2-inch wide opening for expansion joint movement in your deck, but how is it actually ever going to move if there's no opening in your railing? So just make sure that you're carrying your joint opening width all the way through your railing and through your fascia concrete whenever you're doing a joint replacement. See, yep, there we go. Where's the expansion? Make sure you do some good vibration and consolidation of the concrete around the anchors to make sure it's adhered well. And then you're going to cure your concrete in accordance with your local DOT office requirements. Even in part width construction, you can install your gland in one continuous piece all the way across the bridge, just because it comes in a huge roll. So you can start on one end and go all the way to the other end and just leave it rolled up near the center of the bridge as you're switching traffic. If that's impossible to do, and you do need to do it in 2 separate pieces. You have to buy a cold vulcanizing gland repair kit. DS Brown sells cold vulcanizing gland repair kits for splicing glands together, as well as a company called Belzona. In Michigan, we've used Belzona quite a bit to splice glands together. And not only that, if you have really small tears in a gland and you don't want to replace the entire gland, and that's the only spot that's a problem, and you've got the time and energy to do it, you can get one of these cold vulcanizing kits to repair that gland and prevent that leak. Okay. I think that was good timing.
Yeah, that was great. Thanks, Jason.
I was shooting for 45.
I got a question for you, which I get all the time.
Okay.
And I hate answering, so I'm going to give it to you. What's your favorite joint type?
My favorite joint type? Strip seal.
Okay. Do they last the longest?
Yeah, I mean, they properly installed and maintained, you can get 20 years out of them in Michigan.
I'll share my go-to answer to that question, and it was whatever is the favorite joint type of that maintenance district. Oh. And my reasoning was that if I use the joint that the maintenance crew's most comfortable with, they were more likely to be proactive on repairing the joint.
Yeah. No, we got our crews in Michigan set up really well with thinking about those pourable joint seals as being something that needs to be on cyclical maintenance and not waiting for them to be failed. So
okay,
really, and then we like doing that.
Yeah. And then I have one more question that was in the chat here, and anyone else that's on the line, feel free to type anything into the chat here as well. How often should pourable joint seals be resealed typically?
I mean, properly installed, I would wait for a visual adhesion failure maybe, or just think about every 5 to 7 years.
You and I are right synced up here. I said 5 to 8 years if they were done well, but then also highlighted cleaning as your best bet to maintain it and to find out.
Yeah, I mean, if it's not installed properly, I mean, it might fail in a year.
Okay, you're not reading the chat, right?
Properly installed, properly maintained, I'd say 5 to 7 years. Okay. Maybe even as high as 10.
Mm-hmm. And then I think the only other comment I might have is when you showed the foam block out for the steel header joint, I think that works really well. I have struggled with those foam blockouts being well above the joint header elevation, so you can't screed across when we're doing elastomeric headers. We've worked really hard with contractors to try and get it flush with the surface they're trying to go to so that they could screed all the way across both sides, and it has produced a much better ride than what I've seen before.
Okay.
Yeah, but when you have a steel header, you probably have something to screed to anyways, if it's at the elevation.
Yep.
Okay, well, I am not seeing anything else in the.
Yep.
Oh, here we go. We got some more in the chats. We have a question here. Any experience with segmental joints? And I don't know, Jason, I might need more definition on what is meant by segmental.
Joints on a segmental bridge, or
Tregan, if you're interested, you can go ahead and unmute and ask the question.
Yeah, so it's like a compression joint in a way, where it's but it's kind of got like plates segmentally across the joint, and probably it's about 2 to 3 inches thick, and maybe it might be like a foot wide. We had some on all 4 ends of a brand new bridge fail, and within the first year, and we think that it's probably a leveling issue that they weren't installed correctly. But was wanting to see if anybody else had any experience with those or seen any similar issues.
I'm wondering if you're not talking about what typically is called a modular joint.
Yeah, that's what I was.
Okay.
That's what I was thinking. Modular.
Yes, and no.
It's like, is it like 3 or 4 back to back to back strip seals almost, or is it
Kind of, yeah.
kind of?
So with those larger joints that have like the steel bars underneath them helping to support the rails, I have experience with those. Replacing them is typically a nightmare just because you got to like close the roadway usually, and you got to demo a lot of the bridge to get all the way back to where they're or the supports for those rails are. We've tried to band-aid them together with like installing like some different tensioning bars and things to help hold them down. But boy, if you had one that failed that shortly after construction, then I would definitely be pointing to construction defects and looking for someone to fix that, not leave it for maintenance to deal with.
Yeah, these ones aren't the ones that have these aren't the fully modular ones that have the bars underneath that you're talking about.
Okay. Do they come in shorter lengths? Like they're not the full width of the bridge. They're like 6 feet or something in each piece.
So it's not what I'm
yes.
showing on the screen now, where it's a series of.
Is it almost like a rubber? They're like a foot wide.
Yeah.
Okay, yeah. I think you're talking about the. I forget what we called them. Schuylkill Rubber used to make them, but they were like a rubber bolt down joint.
Yeah.
Yeah. They're better.
That's almost like isn't that just a different kind of header material that's a rubber bolt down, and you can replace it with elastomeric, Travis?
No, these are actually, it's a different joint type. Washington, I just saw Washington is still using them.
Okay. I have not seen that in Michigan. I'm sorry.
If you want to shoot me an email, I have limited experience with them because we kind of phased them out in Oregon, but I could find some information on folks that are still using them with maintenance up in the Washington area. Okay, so we have, and then and I had my email address up in the chat there. So let's see, we have another joint from Ian. Other than not carrying the joint openings to the railing, is there any other common issues you see from designers when doing joint replacement projects? I'll let you take the first stab at this one, Jason, but I know that I've made mistakes that I'm willing to share.
I gave an entire presentation to our bridge design squad unit, leader unit at Michigan DOT with all of the issues I saw with bridge joints in Michigan. The main issue we have in Michigan is not when they construct the bridge or they put together the plans. I mean, they don't have enough cross sections at the joints. They like have a cross section at the center line of the bridge and they just assume it's all the way across, and it's not. It changes in spots depending on where you're on the bridge deck. The overhangs can be different. I've seen bridges where we've had a joint opening and then all of a sudden at the overhang it was just poured closed tight. Just not enough details. The most horrible detail you can have is to just say they'll figure it out in construction. Saying that will end up being the worst, cheapest possible solution that construction comes up with.
Yeah, so I'll echo on that one. The most common issue I see is they're an afterthought. So usually there's all this work on the bridge deck being done. all that's detailed well, and then it comes to the joint, and there's an arrow that says see standard drawing such and such. So the width of the joints is often just assumed based on standard or the original bridge drawings, but not field measured. Sometimes the joint widths are way off, right? And so the contractor bids one thing and procures the material, which sometimes can take 6 weeks to arrive, and they get on site and they're like, this is the wrong size joint, you can't use this. And then the other one I've seen is like a lot of engineers pretend that all the deck reinforcement stops in their joint blockout area, but it doesn't usually. And so if you're changing joint types, right, that's the most common is I get calls from the contractor like, hey, I'm hitting rebar everywhere, what do you want me to do? And right, it was like, it would have been great if we would have thought about that during design as opposed to during construction.
Mm-hmm.
I just got a question here. Can we download the PowerPoint slides? They will be uploaded to the website. I sent a link at the very beginning of the chat that will show where both the video and the PowerPoint slides will be loaded to. We got another question here. Do they use hydrophilic joints on the bridges as they do for tunnels, precast RCP segments? I'm not familiar with the term hydrophilic.
That was my question. Hydrophilic just means it expands with water. So
Yeah, no, yeah, bridge joints don't have that. That's more or less like I've used that in segmental box culverts that have leaking joints, and you have active water leaking. You can inject hydrophilic grout into that joint, and as it contacts with the water, it'll react and seal the joint off. But that's just for like culvert joints where there's active water leaking.
thank you.
Here's another question. Any suggestion for joint header concrete type to prevent cracking, such as elastomeric concrete?
Like what manufacturer do we use?
Or our material type?
Material type or?
Yeah, what kind of materials would you recommend for the joint header?
I mean, it all depends on your local DOT. They'll have their recommendations for a header material, what's on their approved products list. Michigan DOT, we've used a variety of fast setting concretes, whether it be a methacrylate concrete such as T17, Transpo T17, or I mean, there's other materials, polyester concretes, epoxy concretes. I mean,
for me, I know that like when you think of header, you think lots of impact loading, and sometimes we gravitate to a higher strength, harder materials is going to be better. And I've found personally that I've had greater success with going towards the elastomeric type of concretes that actually have a lower modulus elasticity, but still a lot of strength, so that maybe they give a little bit more, because you're having all that impact loading, and a little give, I think, reduces your cracking problems. There's a lot of different variations when you say elastomeric concrete. I don't know that I personally have a preferred type, but I tend to gravitate towards that set of materials for header material.
Yeah.
Thank you.
Okay. Well, again, I'll just remind you that there is a link up at the top to where you can download this presentation, and then actually other ones that we've given. Our next training is going to be in 2 months. So look for a flyer sent out in November, and it's going to be on common maintenance scour repairs that can be done. It's actually, there's a lot of information in this one that'll be about like crew level scour repairs where the crew's performing it, but I've seen it before. It's a great presentation on things you can start to do now to address some of your scour issues. So with that, I'll thank everyone for signing on. Thank you, Jason, for putting this together. This was fantastic. And hopefully we'll see lots of you in November.
Yeah, good
Yeah.
afternoon. One question. How can I download this presentation?
The presentation will be loaded to the website, and I can type in the link again here. And usually we get it loaded in, I don't know, maybe less than a week. I just typed the link into the chat window. Did you see that?
Payment reservations.
Yeah, that's the link that it goes to. Payment Preservations are parent group, I guess. So if you click that link, it'll take you to the TSP2 local agency presentation library. And in that library, it has lots of different training options. And this one will be added to it. And so it has the video and the PDFs of the presentations.
Thank you.
Okay, yes, Tiffany, yeah, I just sent the link again.
Thank you. Some nice presentation.
Thanks.
Yeah,
Yeah,
all.
thanks, Jason. Thanks, Travis.